Alright, so hopefully you've already gone and done your research. This is kind of a summary of what you should have found. First of all, arc length is the distance along a curved line making up the arc from, well, actually we're not going to be able to fill in that till we figure out this. This is called the initial side. Every angle we are going to make is going to start there and go somewhere else in the circle. Hopefully you know all the way around would be 360 degrees, but we're going to talk about that in a minute. The ending side of an angle is called the terminal side. Like the Terminator, it ends right there. Well, that's what arc length is. It's the distance along a curved line making up an arc from initial side, and this is not on the notes in the computer, to the terminal side. So in other words, the angle from here to here is the arc length. Central angle is the angle formed from the initial side through the center to the terminal side. There are four main stops. Well, you can probably guess how many degrees are in that angle because look at the angle it forms. That is a 90-degree angle. Okay? Or, if I go the other way, negative 270 degrees. And that gets into whether I go counterclockwise, which is positive, or clockwise, which is negative. If I go here, that is 180 degrees. And then, or, if I go the other way, it would be negative 180 degrees. This to here is 270. If you can tell, I'm just really adding 90s because this would be 90 plus 90 plus 90, and that's kind of important. Or if I go this way, it's negative 90 degrees. And a full rotation, hopefully you know, is 360 degrees. Okay? This actually is or 0 degrees because I wouldn't go anyway the other way. Now, what do I want to do next? Well, I want to talk about the measure of the angles given here. If one box is 90 degrees, one quadrant, if you prefer, is 90 degrees, then what is this entire angle? Well, to find that, I would just go 90 plus 25. If I had to go backwards, it'd be subtraction, etc. So the answer here is simply 115 degrees. It's as simple as that. You try 2 and 3. Press pause. Try 2 and 3. This is 180 to that point, and I got to go 60 more. So 180 plus 60 gives me 240 degrees. I better check. Am I going counterclockwise? Yep, so it's positive. I'm good. This one, on the other hand, is going clockwise. And it's kind of confusing because it looks like it's starting here, but basically what it's saying is, here's my initial side, to there is 20 degrees. What is the rest of the circle? Well, if a full circle is 360 degrees, and I take away 20, I'm going to get 340 degrees. Now again, this is going clockwise, so the answer here is negative 340 degrees. Double check, do you have a negative? If you don't, put it there and maybe put a big oops or something like that so you know what you're talking about. Next thing you're going to talk about is coterminal angles. And coterminal angles are two angles who share a terminal side. One angle is always positive, and one angle is always negative. So, in this picture down below, this is super easy, guys. If one's positive, one's negative, and they add up to the terminal angle, we'll look at number 4. That means this angle and this angle. What do those angles have to add up to? Well, it's a full circle, so 360 degrees. So if I take 360 and subtract the one given, I should always get my angle. And then I just got to determine, is it positive or negative? And if I'm going clockwise, we set up above, that's negative. You try 5 and 6. Press pause, try 5 and 6. So this one I'm going counterclockwise, so it's going to be positive plus. Look, there's a negative already given. We set up above, one's positive, one's negative. So if a positive's given, I better have a negative answer. If a negative's given, I better have a positive answer. And again, 360 minus 135 gives me 225. It's counterclockwise, so it's positive degrees. Done. This one, a positive is given. I probably better get a negative. Again, 360 minus 195 is 165. I'm going clockwise, so it's negative. And there's my solution there. So easy, guys. Nothing wrong so far. It doesn't get crazy harder. There's just some more things to throw at you. Let's go to the next page. All right. So, definition of radians is a unit of measure for angles, and this is similar to degrees, like degrees. It's just another way to measure it. Now, 1 radian is about 57.3 degrees. It's kind of a little hint there. Is the angle made at the center of a circle by an arc equal to the radius of the circle. That's not going to make sense yet. It may never make sense. What you need to know, though, is how to convert from degrees to radians, how to convert from radians to degrees. So, to convert from degrees to radians, maybe we should circle that. We're going to use that formula right there, which says take the degrees, times it by pi, divided by 180. So literally, I'm taking these degrees, times it by pi, divided by 180. So I'm literally just simplifying here. 10 goes into each of those, so I'm going to take that out. 6 goes into there once, 6 goes into there 3 times. I end up getting 1 pi over 3, which is just pi over 3. We can get rid of the 1. Number 2, same thing, times it by pi over 180. It is this simple, ladies and gentlemen. 9 goes into there once, 9 goes in there 20 times. You may need a calculator for that, but don't make it harder than it is. And reduce it until you cannot reduce it any further. And the answer here is pi over 20. Sometimes you're going to get a 2 or a 3 or a 4 up here. It's not always just going to be a singular pi, but it should be reduced as much as possible. You try, press pause, try 3, 4, and 5. Like I said, it's not always just going to be a singular pi. And on number 4, we get our first example of it. Now here's what I'm forgetting. If there's a negative there, I better have a negative in my answer as well. And it can be more than pi. These are all fractions under pi, but this one, well, 60 goes into here 5 times, 60 goes into there 3 times, and I get 5 pi over 3. And that's okay to get too. Okay? Positive and negatives, they can go any way you want. So it makes sense if I'm times it by pi over 180, to go the other way around, from radians to degrees, we want to use this formula, which says times by 180 over pi is the reciprocal relationship that they have. So I'm going to take, say in number 6, 2 pi over 3 times 180 over pi. And what's the first thing you notice? Hopefully that there's pi on top and pi on bottom. They cancel each other out. Which makes sense, because if I'm trying to change these to degrees, I'm not going to say it's 30 pi degrees. It's 30 degrees, etc. What else? I can cross cancel here. So 3 goes into there once, 3 goes into there 60 times. What's left? 2 times 60, 1 times 1 is 120 degrees. Again, you may need a calculator, especially for one like the next one. Again, the pi's always cancel. 4 goes into there once, 4 goes into there 45 times. Again, something you probably want a calculator for. Then multiply across. 3 times 45 is 135 degrees. Press pause. You try 8, 9, and 10. There you are. Same thing over and over. Check your answers to mine, and let's move on here. So, given the information that we have here, I want to label the following 4 pictures in radians instead of degrees. And you can see I've given them all to you in degrees. How do I change it to radians? Well, we just got done doing that. 90 pi over 180 is pi over 2. Well, you could do the rest of them, but I'll just give it to you. Those are going to become significant later this week. Next page. Hopefully you already went to look up reference angle. Reference angle is the positive acute angle that connects the terminal side to the x-axis. And this is always less than 90 degrees, or less than pi over 2 if it's in radians. Okay? So what do I mean by that? The example says, find the angle shown in the diagrams below as well as the reference angle corresponding to it. So I want to give it in degrees if it's given in radians, and then I want to give it in radians if it's given in degrees, just kind of going back and forth. This isn't that hard. If I want to figure out what this is in degrees, this given, the angle measure shown, as well as the reference angle. So I'm going to find the angle measure shown by just going 7 pi over 6 times 180 over pi. Those cancel, and I get 210 degrees. Now, I also want the reference angle. And the reference angle is the acute angle that connects the terminal side, this right here is the terminal side, to the x-axis. So it's this right here. What is this angle? Well, if this whole thing is 210, and then this to here is 180, what's left? Well, 30 degrees would get me back to that axis. I'm looking for that angle right there. So for instance, in degrees, I want to change that to radians first, so I'm going to put 135 degrees times pi over 180. I'm going to reduce it to 3 pi over 4. And what I want is the rest. Well, if I have the whole thing, we said this on the previous page, up to here is pi. 3/4 of it goes this far. What's left? Well, pi over 4, 1 pi over 4. Now if you don't know how to do that, what I'm really doing, instead of taking 180 minus, I'm going to go pi minus 3 pi over 4. And to subtract, you need to have common denominator, which is just 4. So if I multiply the top and bottom by 4, it's just 4 pi minus 3 pi, which is 1 pi. If you put that, that's not wrong either. Okay. On to the next one. I want you to try the other two here, and then double check yours with mine. Negative 300 degrees is the entire thing. It's negative because I went clockwise, and I want this, which is going to be, well, if the full circle is 360, what's left here is 60 degrees. It must be positive, it must be acute. Alright, so let's go to the last one here. I'm just going to simply go like this to get it real easy to be negative pi over 3. Now, what is this angle going the other way? Well, this is the easiest of all of them, because if going this way is negative pi over 3, then going this way is just pi over 3. There's nothing to do, it's just given to us. Okay? If it's in the first or third or first or fourth quadrant, it becomes very easy. Alright, hopefully that made some sense. Let's go on and kind of see it, visualize what it is I'm talking about here. Which angle measure is shown in the diagram here? Well, this is 180 degrees, which is, again, if I change that to radians, because that's what this problem is in, the 180s would cancel and it would just be pi. So it has to be more than pi, which rules out that right away, rules out that right away, rules out that right away. It has to be greater than pi. I also know that this is going clockwise, and clockwise means negative, which then rules out that, and there's my answer. Now again, this is over 180 degrees, which is over pi. Had to be a number greater. This is just recognition, folks. That's all it is. Similarly here, this is over 180. It's even over 270. And 270, we said on the previous page, is 3 pi over 2. Well, these are all in terms of 6. I can tell this is greater. It can't be this. It can't be this. It can't be this. It has to be one of these two because it has to be greater than 270 degrees. Those are all real small ones. Well, is it negative or positive? It's going counterclockwise, which means it's positive, which means it can't be negative. There it is. See, a lot of these are just process of elimination. You'll have a few to try on the next page. Now, the reference angles given here to these would be, well, what I want to do here is I want to first change them to degrees because that'll be a lot easier for me. If I go 180 over pi, the pi's cancel. That's 45 degrees. And 7 times 45 is 315 degrees. Now the reason I'm doing that is because I want to probably draw myself a little picture. And I'm going to go, there's 90, 180, 270, 315 is like somewhere over here, right? So really the question is, it's got to get me back to the full circle. Well, a full circle, we said on the previous page again, is 2 pi. If I take away the 7 pi over 4, well, I can't just do that. If I put that over 1, I still can't just do that. But if I find a common denominator, so I multiply the top and bottom by 4, I get pi over 4 as my solution. When they're in radians, it's a little bit harder than when they're in degrees. Okay, this one here, if I draw that picture, negative 7 pi over 6, boy, I don't know what that is. So let's change it again to degrees. 31, negative 210 degrees. Okay, and then, well, where is that? That gives me a clockwise rotation. This is 180, so 210 is somewhere over here. So it's 30 more than 180, which gets me to 30 pi over 180, which is pi over 6. This is not easy. The next two are, but A and B are not quite that easy. Try them. It's not going to be crazy tested on, but it's something I'd like you to try. The next two are pretty easy, because if I just draw a picture with this, negative 150 degrees is somewhere over here. Okay, if this is 90 degrees, then this is 60 degrees, then this is 30 degrees, and that's my reference angle, 30 degrees. It's the one, again, the acute angle from the terminal side back to the x-axis. The acute angle from the terminal side back to the x-axis. Okay, the acute angle from the terminal side back to the x-axis, right here, 240, I'm going to go counterclockwise. There's 180, 270 is too far, so 240 is to here. If this is 180, how much more do I have to get to 240? 60. And that's the angle between the terminal side and the x-axis. 60 degrees. Okay? Your homework is the following 2 pages. It is not as long as you think, even though it's 38 problems. Some of it's going to go super fast, like 19 through 34 should go super fast. Matter of fact, all the way 1 through 34 should go super fast. 35 through 38 is going to be a little more challenging. Look at what we did in the notes, change them to degrees first, and then try and find the values from there. Have a good day.